Okay, guys, our goal today is to continue talking about graphing linear functions. In other words, it's another option. Still not my favorite way to graph, but I think you guys will agree with me it's a little bit easier than graphing with tables. So that's what we're going to do today. If there's time, I would like to start analyzing slope with you, what it is, and how we use it with graphing. The quiz is still scheduled for Friday on lessons 8.1 to 8.4. If for some reason that moves to Monday, I will let you know. Okay? Annalise? Yes, good guess. Okay, so let's start with the warm-up here, okay? So first thing you needed to do was put it into function form. What's another name for function form? Doug? Y equals, and what's another name for it? I mentioned it once or twice yesterday. It begins with an S. Annalise? Yep, slope-intercept form, function form, and y equals form are all the same thing. So important you remember that. What was the equation I wrote on the board yesterday that represented y equals form, which is also slope-intercept form? Annalise? Good. Y equals mx plus b is the general equation for slope-intercept form. Doug? You mean, are you asking me if we're going to be graphing a line that's x equals? Yeah, we're going to do that. We're going to do it by hand, not on the calculator. All right, so for this one, Charles, what did you get for your function form? Yep. Nope. The 2x is right, though. Sean? Good. Briar, what did you use for your table values? What have you been doing the whole time you've been in here? Okay. All right, table values, Adam. Okay. Good job. So the graph should look like that. Mary. That's not correct. So after you minus 4x on both sides, you have negative 2y equals negative 4x minus 8, and then divide everything by negative 2. Okay, you just forgot to divide. Okay, any other questions on number 1, Doug? You flipped them? Yes. Oh, you mean these? Yes. Well, then they're all going to be wrong. Why did you flip them? I didn't mean to. No, it's always x comma y. Doug, be careful with that, okay? Okay, number 2, Zach, could you tell us your function form? What'd you say? You didn't get to it? Okay. Emma. Good. Y equals negative 3x minus 3. Justin, what did you use for your table values? What'd you say? Okay. Alyssa, table values. Okay, and what'd you get? Good job. So the graph should look like this. Annalise? Okay, then your graph, that means your graph is completely different, if you got that. So did you multiply everything by 3 first? So you get negative 6x minus 2y equals 6. Did you get that after you multiplied everything by 3? Okay, well, the 3 here cancels, so these are gone. Okay, Yeah, remember that if you multiply by the bottom of a fraction, it cancels it. Mary? That's fine. Yeah, you still got the same answer, right? Yeah, as long as you just take your time. There's many ways to solve this. I'm just doing it that way because that's how we did in class yesterday. But that's fine, Mary. Doug? Yeah, that's what you told me. Yep. I thought since you flipped them that your graphs were going to be wrong, but don't, on a test, make sure you don't flip them. That way I don't mark them wrong. Okay, Briar. Yeah, same thing. I think that Annalise left it as 6 by accident. She forgot to do that, but you're exactly right. Okay, anyone else on 1 or 2 on the warm-up before we go to the homework? Annalise?
Would it still be right if you did -1, 2, 0, 1, and 2 for x?
Yep. All right, let's go over homework. Okay, number 1 on the homework. Doug, we'll start with you. What is your function form? Good job, and then pick a couple table values and tell us what you got. Okay. Oh man, this is kind of hard to see. Okay, I use -2, -1, 0, 1, 2. I thought this would be easy to see, and it's not. Anyways, so there's the graph, there's function form, and there's my table. Doug's works fine. It does not matter what x values you chose, as long as your corresponding y values are correct. All right, Emma H, number 2, can you tell us function form and then the table? Okay. Table? Probably 3. Okay, good. And then the graph is a positive linear function. Okay, Matt, number 3, function form in your table. No, that part's not right. -4/3 x. Mary? Good. -8. Matt, do you want to look at that? If you don't see what you did wrong, I will go over it. Table values, I use -3, -4, 0, -8, 3, -12, -6, 0. So basically, I guess, Matt, the first thing that you can do is you could multiply everything by 6 first. You did? Okay, so let me do it your way here. Okay, so Matt, after you multiply everything by 6, tell me what you got. Oh, you know what? I must have not changed my problem. Never mind, Matt, you are right. Mary, you and me, I don't know what we were doing. Oh, yeah, Matt. Matt, now I'm going crazy here. 6 times -4, you forgot. Mary, never mind. We're good. Mary, I was doubting us. Emma, I was doubting us. Sorry about that. Anyways, so now I'm doing what you did do. Be careful with that. That 6 has to be distributed to every single term. Don't do all the fractions and then think, oh, I'm done multiplying things. And Matt, if you draw these lines, that's helpful too. Sorry. So never mind. That is what it should be, now that I'm extra confusing you. You didn't do that on all of them, did you? Okay. Mary. Yeah, that's fine. You're fine. Yep. Let me, Mary, does your graph look like this? Okay. As long as the graph looks like mine, there's many numbers you could use. Annalise? Yeah, that's what Matt did. Don't do that. Matt, we just talked about that with Matt. You have to. You can't change the value of the equation. So in other words, you have to multiply every term by that 6 or whatever the number is. You can't just choose 2 to multiply it by, because then you're changing the equation so it's not an equivalent equation. So that's completely wrong then. So you have to multiply every single term by 6. All right, number 4, Alyssa, function form and then your table. Good. Okay. Good job. And the graph is a positive linear function. Annalise? What should you always write first? Remember yesterday we kept talking about in function form, what always comes first? The x or the number? The x always comes first. So, I mean, I wouldn't mark it wrong, but you should try to get into the habit of putting that x first. And we're not done using function form. We're going to keep talking about it throughout this whole chapter, but try to get better with keeping that x first. Okay, Donatus, number 5, function form, and then I guess tell me what your function looks like. Okay. Okay, good. Negative linear function, I used -2, +1, -1, -2, 0, -5, 1, -5, no, sorry, 1, -8, 2, -11. Can't read my own writing here. Okay, Adam, number 6. Good, and then table values? Yeah, tell me all of them, yeah. Good. Perfect. Okay, and then you have positive linear function. Matt. Since it's set on this function form, ... probably not. But anytime you're writing an equation in slope-intercept form or function form, you should put y equals. So for this one, it's okay. All right, Charles, number 7. Okay, table. Good job. And I used an extra one, so if you guys have an extra one. Negative linear function here. Make sure your function form is correct. Okay, Sean, number 8. Good. And table value, Sean? Good job. And positive linear function. Okay, Justin, number 9. Okay, I would keep it as 5 over 2x minus 5, just because remember, this should be a fraction. This should be a nice number or a decimal. Justin, what about your table values? Good job. Annalise? No. So you minus 5x on both sides. So we have -2y equals -5x plus 10. And then divide everything by -2. Negative divided by a negative is a positive. Yep. Number 8, did you multiply everything by 6? Okay. Let me just go up here. Okay, so Annalise, when you multiply everything by 6, tell me what you got after you distributed 6. Well, yeah, but you still end up with nothing, because 6 times 0 is 0. So just tell me what you have so I can fix your mistake here. You mean positive 4. Oh, okay. So 6, okay, Annalise, let's just do it again. 6 times 2/3 is what? 4x, okay? And then 6 times -1/6 is minus 1y. And then 6 times negative 1/2 is minus 3. Okay, all equal to 0. And then all you need to do is add the 3 to both sides. 6 times negative 1/2. You okay? You want me to keep going? So you have 4x minus 1y equals 0 plus 3 is 3. And then minus 4x on both sides. And then we get negative 1y equals negative 4x plus 3. And then divide everything by negative 1. And that's how you get y equals 4x minus 3. Okay, Mary? It's okay, but you should keep it as a fraction. I wouldn't mark it wrong at this point, but when we start graphing, it's very important to keep that as a fraction. It is. You'll see why, but at this point, I would not mark it wrong. Nope. Annalise?
So like if you have a third number that doesn't have an extra y, you can do that one first.
You can. It doesn't matter. There's no rhyme or reason because you're still going to get to the same answer. So you could either move the 4x first or that negative 3. Jeremy? Three's enough. Yeah. Okay, anyone else on the homework? Give me a thumbs up, thumbs middle, thumbs down on the homework. Okay, thank you. All right, let's go to our notes, and we're going to go to talk about x and y intercepts today. So this is page 9. So again, this is page 9, section 8.3. This is the second method that we're going to talk about of how to graph. Now, graphing with tables, okay, kind of a pain, kind of tedious. This one does not take as much time. Still, I don't think it's the most efficient way, but you need to understand what an x and a y-intercept is when we're graphing. Anyone want to take a guess to tell me what the x-intercept is? Briar? Good. What is the y-intercept? Jeremy? Good. So here we go, page 9 of your notes. An x-intercept is the x-coordinate of a point where a graph crosses the x-axis. The x-coordinate of a point where a graph crosses the x-axis. And if you want to draw a little picture, it might be a good idea. The x-intercept is always written as a number, comma, 0, because it's always whatever the x-intercept is, comma, 0. When you're graphing it, it's how many you go to the right or left. There should be a golf pencil on my desk if you don't know where your pencil is. Okay, well, go get another one then. Just make sure those go back at the end of class, okay? Okay, and if you write down the ordered pair, the x-intercept, comma, 0. The y-intercept, the y-coordinate of a point where the graph crosses the y-axis. So right here would be your y-intercept. The ordered pair is always 0, comma, whatever the y-intercept is. You will see x and y intercepts with all types of function graphs. So quadratic function, absolute value graph, all those different functions we learned about, okay, you will see the x and y intercept for each of those. You'll find them for each of those. Charles? Correct. Very good. So if they're just a real quick side note, Charles, and we'll talk about this more later, but if you have a quadratic function and it looks like this, and I asked you, what are the x-intercepts? What would you say, Charles? Yeah, they're imaginary. They don't exist. That's when imaginary. Ooh, how do you know about this? Okay. When you graph it, there could be a real and an imaginary plane, and that's what a complex number is, something like 3 plus 2i. So yes, but you're way above where we are right now. Okay, I'm not going to talk about that. That would take me much longer than a minute to explain. Okay, sounds good. All right, any other questions back to pre-algebra on x and y intercepts? Okay, so let's do an example. All right, number 1. Okay, this is pretty basic here. Find the x and y intercepts graphically. Do you guys have a graph on your paper? Okay, let me just draw this real quick. I don't know why mine's not here. All right, so here's the graph that's in your notes. Just by looking at that, what ordered pair represents the x-intercept? MH? Good. -1, 0, and I'm just going to write the ordered pair in. Okay, Jeremy, what ordered pair represents the y-intercept?
0,
Good. 0, -2. So just by looking at the graph, this is the x-intercept, this is the y-intercept. You guys with me on that? Okay, the second one. Let me see where your second point is. All right, so based on your graph, let's start with the x-intercept. You guys have to estimate on this one. What is the x-intercept? And your graph's a little more detailed than mine. Donatus? Yeah. Positive or negative? Good. -2/3, comma what, Donatus? Good. Comma 0. So there are times when your x and y intercepts are not going to be perfect. Just estimate. It's going to be very hard to tell exactly what it is since you don't have an equation. I'm going to show you how to do it with an equation. And what's the y-intercept? Alyssa, what's the y-intercept? Good. 0, comma, +2. So if you round the x-intercept differently, that's okay. You might put -0.6. Okay, you might put -0.65. You can round that differently. Annalise?
how did you get rid of
Right here. It's a little more than -0.5. So Donatus just chose a number. Say that again. Okay, that's good. So you had a reason. Okay, I'm sorry, Donatus. Donatus had a reason. I'm going to show you how to do it algebraically. I didn't know you already thought through it like that. That's good. So Annalise, for now, you're just estimating. Okay? All right, let's go to the back page, page 10 of your notes. Okay, so this little box here tells us how to find x and y intercepts using algebra. Okay, so number 1, to find the x-intercept, we plug 0 in for y, we solve for x. And then number 2, to find the y-intercept, we plug 0 in for x and we solve for y. Bless you. So for the y-intercept, we put 0 in for x. For the x-intercept, we put 0 in for y. It's always the opposite because you need to find the x, put 0 in for y. Then when you have to find the y, you have to put 0 in for x. So you don't need to draw this, but just one more time, a reminder. If it crosses the x-axis, that's your x-intercept. So it's always what the x-intercept is, comma 0. To find the y-intercept, could be any of these. Put a 0 in for x, solve for y. You don't have to write that again, just the visual. All right, so let's do the first example together. Okay, find the x-intercepts for the equation x minus 2y equals negative 2. I want you guys to write down x-intercept, put a box, y-intercept, put a box. Okay, let's find one at a time here. Okay, Zach, to find the x-intercept, where do we put 0? Good. So we need to put 0 in for y. So we have x minus 2 times 0 equals negative 2. What'd you say? Did you say it's so easy? I know, isn't it? So Doug, what's negative 2 times 0? Doug, what's negative 2 times 0? Okay, be serious. 0. So we have x minus 0, which is just x, equals negative 2. So Mary, can you write that as an ordered pair for us? Good. Negative 2, comma 0. Jeremy, how do we graph negative 2, 0? Good. So there's our x-intercept. Really hard, I know, right? Charles? For now. For now. Trust me, I understand. Sometimes, yeah. Trust me, I'd rather be teaching you guys like slope or graphing this, but you have to know how to do this. Yes, I'm showing my work just for this one. Okay, ready? Sean, for the y-intercept, where do we put 0? Good, we're going to put 0 in for x. Are you ready? 0 minus 2y equals negative 2. Donatus, what's 0 minus 2y? Good, negative 2y equals negative 2. Adam, what's y? Good, that's our y-intercept. So Briar, what's the ordered pair? Good, 0, 1. Zach, how do we graph that? Say that again. I just can't hear you. How do we graph 0, 1? We go, say it one more time. Just can't hear you. How do we plot 0, 1? Good, go up 1. Over 0, up 1. So look, guys, we have 2 points. We connect them. There's our function. So just real quick, raise your hand if you like graphing with a table better than this. Okay, raise your hand if you like this better to graph. Okay, that's what I figured. Based on what we've learned so far, I agree with you. I think this way is quicker. Now, like Charles said, do you have to show all of your work? No, but I need to see your ordered pair of what the x-intercept is and what the y-intercept is. Okay? Annalise? Not for x and y-intercepts. To find an x and y-intercept, it does not have to be in slope-intercept form. No. The form that's in is actually called standard form. Typically, whenever you're finding intercepts, it's always in standard form because it's easier that way. Okay, I want you guys to try number 4. So that next example, go ahead and find the x and y intercepts, write it as an ordered pair, and then graph. When you're done, just hang out for a minute till everyone's done. Oh, geez, you're flying through it. No. Oh, these are right. You just have to graph them differently. Here, do your graph like this. Make this the axis, the y and the x. Make this the y-axis. Make this the x-axis. That's why. Your graph's just, you know what I mean? Not the other guys. When you're done with that one, go ahead and try the top one on the next page. Good. I don't know why the numbering. Don't worry about it. Very nice. Let me see. Yeah. Don't worry about that right now. Okay. You guys are really good at this. Okay, about another minute or so to finish up. And then I want to do the word problem with you. So when you're done with that second example, just hang out till everyone's done. That's all right. What did you say? I'm not sure yet. I have two different things we could do. I just wanted to see how you guys were doing with this, but apparently we're doing very well. You guys surprise me sometimes. All right, Justin, what did you get for the number 4 on page 10 for your x-intercept? Good. Emma M, what did you get for the y-intercept on page 10? Good, 0, 4. So our graph should look like this. So questions on page 4. Annalise? Yeah, that doesn't matter. I know. It's the formatting. That happens a lot. Questions on number 4? Sure? Okay. Next one. So page 11, very confusing, but number 3 at the top, Annalise brought that up. The formatting just gets changed sometimes. I don't know why. So Alyssa, for number 3 on page 11, what did you get for the x-intercept? Good. X-intercept is 3, 0. Matt, the y-intercept? Good. 0, -1. So 3 zeros here, 0, -1 is here. So still a positive linear function. Remember, you're using the intercepts to graph. Questions on how to do that one? Easy, huh? Okay. Let's talk about the word problem, and then I'll get you guys your homework. Okay. So it says, while at the beach, oh, this makes me jealous. Okay, while at the beach, you rent a boogie board. Sounds like fun. For $1 per hour, or a surfboard for $2 per hour. You have a total of $10 to spend. Okay. Write and graph an equation describing all the possible combinations. So the first thing is, what is x and what is y in this problem? And I don't know if you guys are going to be able to figure that out. Mary? Okay, good. I always spell boogie board wrong. So boogie board hours is x, very good. Y is surfboard hours, or you could say the hours you spend boogie boarding and the hours you spend surfboarding. Why is that x and why is that y? Anyone know? Charles, why? Okay, correct. Why though? Very good. So yeah, you could have them switched around. What I typically tell the 9th and 10th graders is whatever word comes first is x, whatever comes second is y. It doesn't matter. Okay, you have a total amount of money to spend, and there's 2 different activities that you are doing, or there's 2 different activities that you want to do. Okay, so whatever comes first is x, whatever comes second is y, typically. Okay, so anyone want to try to write an equation based on these pieces of information we have? Annalise, what do you think? Wow, you guys are awesome. I should have you guys in my algebra class. Wow. Everyone hold on. No, you're not doing the same thing. This is similar, but their stuff's harder right now. I'm not saying you guys couldn't do it. I just have to try to stay to your book, or else I'd be teaching you algebra, which is next year, and I don't want to get in trouble. So, is everyone clear on how we get that? Mary? Yeah, okay, that's why I'm asking. Is it, anyone want to explain that? If not, I'll explain. Emma H? Yep. Okay. Anyone want to add anything? Jeremy? Good job. So basically, Mary, everything they said is correct. This is the total. So anytime you're given a total, it's going to be in a number x plus a number y equals the total form. So like the 1 relates to boogie board because it's $1 per hour. The 2 relates to surfboard because it's $2 per hour. So it's going to be all the x's and y's on one side, the total on another. Does that make sense? Okay, let's find the x and y intercept, if you haven't already. So if you haven't already found the x and y intercept, go ahead and do that. Yeah, it is. Where's the homework? Yeah, I think you can start that if you want. Okay. I know you're done with the other thing. All right, Donatus, what's the x-intercept in the surfboard problem? 10 what? Good, 10 comma 0. Charles, what's the y-intercept? Good, 0 comma 5. Now, when you guys are graphing this, I recommend using this as the y and this as the x. Okay, x is boogie board hours, and y is surfboard hours. I just think it's easier to kind of make the y and x axis on the left and on the bottom. And then I'm just going to count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 1, 2, 3, 4, 5. So once you have your graph set up, I just counted by ones. Just plot them. 10 zeros right here. 0, 5 is right here. Connect them. Now, before we do the closing, questions on how to graph it. Charles? Right. Yeah, it's right. I agree with what you're saying. It's kind of weird. Right, exactly. Right. So really, I shouldn't have the arrows there. But again, for this class, we're keeping it like that. You're thinking above us, but you're right. It's kind of weird that it would keep going because you can't have negative time. All right. So any other questions or comments on the graph? Okay, so in the closing, number 1, okay, if you didn't answer this yet, let's talk about this. What does the x-intercept mean in relation to the situation? So how can we explain the x-intercept? Doug? You gotta explain it. Explain it. Annalise? So if you spend 10 hours boogie boarding, keep going. If you spend 10 hours boogie boarding, x-intercept. If you spend 10 hours boogie boarding, you spend 0 hours surfboarding. This, you're just explaining the x-intercept. So there's, Annalise, you only have $10. One situation is if you spend 10 hours boogie boarding, then you can't surf. So all we're explaining is the x-intercept. So how do we explain the y-intercept? Justin? Good. If you spend 0 hours surfing, you can't boogie board. Or you could say you spend 0 hours boogie boarding. Yeah, right here. Oh, yeah, I thought I wrote 5, sorry. I swear I wrote 5 and it changed. So, what did you say, Donatus? Right. There we go. So anyways, if you spend 5 hours surfing, then you're not going to be able to boogie board. Now, you can say this differently, but I want you guys to be able to explain what the x and the y-intercept means in regards to a problem. I don't want you just to be able to figure it out. I want you to do more than that. Okay, Doug, is this a question? Okay, Mary, question? Good. Yeah, but this is simple. I agree, but The book isn't complicating it. Donatus? Yes. Because there's many other combinations. Yep. Is this a question? No. Okay. All right. Let me explain homework. Okay. 8.3 in your packet. Go ahead and open up. No, I didn't say no homework. I just said I'd be easier on you guys. Hey guys, be honest with me. This lesson was not hard, right? I'm not like racking your brain. Okay, hold on. Shh. No, just wait. I'm not done assigning homework. Give me a second here. Okay, I just want you to do the odds. Okay, quit complaining. Quit complaining. Okay, now listen. Listen. Here's what I'm saying. Okay, we are moving on to slope tomorrow. Now, I'm pretty confident you guys understand this, but please make sure the odds are done for tomorrow. I gave you the odds because there's only one word problem. I don't want to hear you complaining. I know you have PSSAs, but all you're doing here is finding the X and Y intercepts. Please, listen to those of you that don't show work. Write the ordered pairs on here and graph. Okay, the directions tell you what to do, but some of you guys don't read directions. Write the ordered pairs on here and graph. Jeremy. It doesn't matter. Doesn't matter. Annalise? Oh, yeah, that's fine. Yep. Yeah, if you guys need to use blue sleep, that's fine. All right, get packed up. Good job today. Emma, is your mom or grandma picking you guys up? One of them?